Hello everyone. So in this video, we're going to talk about the cost of recursion. Well, and the reason you don't see my face is my webcam stops working. I don't know why, but that's why. But anyway, let's get right to it. So I don't know if you kind of sense this recursion is kind of one of my favorite topic. I do really like recursion because it's such a powerful and elegant way of solving problems. Right. So if that were the case, then can we use recursion all the time? Right. That's the question. Why we can right we seem to be able to do most things that a loop can do with recursion. Why don't we use it all the time? Well, so if you remember this when we talk about when we introduce the idea of recursion is that recursion uses a call stack. And actually, the reason that recursion is so powerful and so elegant is because it makes use of the call stack. Right? In this example, the sum example, I show the call stack of sum of 3, and that results in 4 calls to sum. So now imagine if we try to solve the problem of, say, sum n equal to 1,000 or 1,000,000, how big is this call stack going to get? It's going to be pretty big, right? So let's actually give that a try. So I have here the iterative sum. I use it to print it out once, and then I have the recursive sum. And then I use it once, and again print out n. I'm going to start with n equal to 100. That should work. So both give me 5,050. Now if I increase it to 1,000, what happens? Well, it's kind of hard to see. So let me, because the thing is interspersed, let me actually comment it out the recursive version first. Okay, and I'm just going to run the iterative version. All right, so that works. I'm going to now comment out the call to the iterative version. I'm going to let the recursive version of sum run, and we run into an error. And what does this say? It says the maximum recursion depth exceeded. Okay, so we cannot recurse so many times. Okay, now why is that? Well, basically Python is trying to protect us. Doesn't want us to do recursion too many times. And well, granted, there is actually, so I believe the limit is 1,000. So if I change this to 999, it will work, right? No, it won't. Okay, never mind. I probably should have figured out exactly what the limit is. And there is a way to change the limit so that I can actually get sum of 1,000 to work. But eventually, I mean, if we go even higher than 1,000, million or billion, at some point the number gets so large that we are actually going to run out of memory because of the call stack, right? I mean, we're going to run out of room. The amount of memory inside the computer is limited, and every single one of these activation record, that's what they call, every single one of these take up some room in the memory, and if the recursion happens so many times, we will run out of room to store all of them. Okay, so there is a memory problem, and then the fact that for every single call we have to push and pop things to the stack. It also means that's an overhead. So recursion is in general slower as well. Okay, but you look at the iterative version going to comment out the recursive version now. The iterative version, I mean, we saw that it can solve a problem for sum of 1,000. We can go up to 1,000,000. I'm pretty sure that still works. Takes a while, so it doesn't break a sweat. It continues to work fine. So this is one advantage that the iterative version would have over the recursive version. So is that it though? I mean, should we just give up on the recursion? Well, no, not quite, because there are actually techniques to reduce the cost of the recursion, both its cost of memory and as well as the cost of speed. Some of these techniques are called tail recursion, memoization, etc. But those techniques are kind of beyond the scope of this course. And also, even without those techniques, we really should not give up on recursion, because it's oftentimes a very natural and very elegant way of solving a problem. And sometimes it's the recursive version. It would be a whole lot simpler than the iterative version. And in a little bit, not in this video, but in a separate video, we will see like a more elaborate example of using recursion to solve problems. So anyway, so we have the tools of iteration and recursion, right, and other things that we've learned. So it's important to understand what our options are, and then given a particular problem, as long as we know what kind of tool we can apply to it, and we understand the cost, the trade-off between each one of them, then we can pick the right approach to solve whatever problem that we're given. So anyway, here's kind of the lesson that we should get out of this, is that there are always trade-off between any sort of techniques or options. So there's really no such thing as a free lunch. But know your options, understand them, and then you can figure out the right tool. All right, I think that's the end of this video.